Hi everyone, welcome back to AE and FGOE 123. This is assignment 5. In this assignment, we are going to practice to use nodal analysis. To use nodal analysis to analyze a circuit, we mainly go through 4 steps. In short, it's called SAS. S-A-A-S. First step is select. We select a reference node as ground. At that reference node, the voltage is 0, for example here. The second step is to assign voltage. We assign the voltage for each node. For example, this is V1 and this is V2. The third step is apply. We apply KCL to each node. For example here, we apply KCL, and similarly for this node, we apply KCL. So that's apply. And the last step is to solve equations. The equations are a system of KCL equations. Question P2.49. Write equations and solve for the node voltages shown in figure P2.49. Then find the values of I1. Well, for this question, let's go through the 4 steps. The first step is to select the reference node. So, well, for this question, it has selected for us, and that's not here. And that would be our ground. We have its voltage as V is equal to 0. The second step is to assign. We assign voltage to each node. Well, here we have mainly 3 essential nodes. That's here, here, and here. So other than the reference node we chose here, we assign this to be V1 and this to be V2. Well, then comes to the most essential step, step 3. We apply KCL to each essential node. So in this case, we have three nodes in total, and 2 nodes are where we are gonna apply the KCL. That's node 1 and node 2. We assume that the currents flow away from these 2 nodes, and we can thus write 2 equations, 2 KCL equation. So we have here the 1 current flowing entering this V1 node. So we have -1 and plus. We have V1 minus 0 divided by 20 ohm, that's Ohm's law, to calculate the current. And we have V1 minus V2 over 10, that's equal to 0. So that's our first equation. And we apply KCL to the node 2. And we have V2 minus V1 divided by 10 plus V2 minus 0 divided by 5. And similarly, this current flows into this node, so we minus 2, that's equal to 0. Then come to our last step to solve these 2 equations. Well, let's first simplify them. For this one, we multiply 20 to all the expressions, to all the terms. So we have minus 20 plus V1 plus 2V1 minus V2 is equal to 0. And we simplify this. We have this is 3V1, so that's 3V1 minus V2 is equal to 20. And let's simplify this one. We multiply 10 to each term. We have V2 minus V1 plus 2V2 minus 20, that's equal to 0. And we have minus V1 plus 3V2 is equal to 20. So these 2 are the equations we have, and we have a few ways to solve these 2 equations. The most straightforward way we learned in secondary school is to substitute one variable into another equation. For example, here we have 3V2 minus 20, that is V1. So we substitute in V1 here, then we are going to have 3V2 2 minus 20 minus V2 is equal to 20. Sorry, this is 2 here, and 2 here, and 2 here. And let's simplify this. We're gonna get 7 V2 is equal to 80, and V2 is 80 over 7. So we have V2 is equal to 11.43 volts. And then we substitute in the V2 here, and we can solve that V1 is equal to 14.29 volts. And our goal is to find the value of I1. So I1 flows from node 1 to node B, that's here. So we have, by using Ohm's law, we have V1 minus V2 divided by 10. And I1 is going to be equal to 0.2857 amp. So that's our I1. Question P2.52. Given R1 is equal to 15 ohm, R2 equal to 5 ohm, R3 equal to 20 ohm, R4 equal to 10 ohm, R5 equal to 8 ohm, R6 equal to 4 ohm, and IS is equal to 2 amp. So for the node voltage shown in the figure P2.52, well, in this circuit, we are given the resistance value for all of the resistors, all of 1, 2, 3, 4, 5, 6. We have 6 resistors in the circuit diagram, and we are asked to solve the node voltages. Well, we are going to use the nodal analysis. So we go through the 4 step. Select. We first select a reference node as ground. Well, for this question, it has done for us. That's the node here. So we have the voltage here to be 0. And secondly, we need to apply the nodal voltages. Here we have V1, V2, and V3. So we need to find the nodal voltage for V1, V2, and V3. That's the second step. Well, then comes to our third step. Our third step is to apply KCL. So similarly, let's first apply KCL to node 1. Assume all the voltages, all the currents flow away from this node. So we have V1 minus 0 divided by R3 plus V1 minus V2 divided by R4, and plus IS. IS equals 2M, so we know that its value, that's 2M. So plus 2 is equal to 0. Well, then comes to the node 2. Assume all the currents flows away. So we have V2 minus 0 divided by R5 plus V2 minus V1 divided by R4 plus V2 minus V3 divided by R6, and that's equal to 0. Well, for the node 3, we have all the currents flowing away. Assume V3 minus V1, because we have a current source here. So similarly, we have that S minus IS. And then we have V3 minus V2 divided by R6. Then V3 plus V3 minus 0 divided by R1, that's equal to 0. Well, for this question, we know all the resistance value, R3, R4, R5, R4, R6, R6, R1. And we also know the IS. So we only have 3 unknowns, V1, V2, and V3. We have 3 unknowns and 3 equations, so we can easily solve this system of equations. So let's substitute in the numbers. We have R3, that's 20 ohm, and R4, that's 10 ohm, R5, 8 ohm, R4 is equal to 10 ohm, and we have R6 is 4 ohm, R6 4 ohm, R1 equals to 15 ohm, and Rs is equal to 2 amp. So we can simplify this equation by multiplying 20 here, and then simplify this equation similarly for the second and third equation, and we can find V1 is equal to negative 12.22 volt. V2 is equal to 1.667 volt. V3 is equal to 5.055 volt. Well, in the midterm, that's how we are gonna solve this type of questions. Well, in our model solutions, we'll see that we can use the MATLAB to find the solutions for this type of a system of equations. Well, in the actual exam, we may not be allowed to use a computer or use a MATLAB, but the questions in the midterm does not require us to have a very intensive mathematical calculations, and the numbers are typically easy to calculate with. So that's how we are going to solve this type of questions. Question P2.51. Given R1 is equal to 4 ohm, R2 is equal to 5 ohm, R3 is equal to 8 ohm, R4 6 ohm, R5 8 ohm. So we know the resistance value for all of the resistors, and we have Is equal to 4M. We are going to use the node voltage method to calculate the node voltages. Well, similarly, we go through the fourth step as SAAS. So the first step, select a reference node, and it has selected for us. Here is the ground. And the second step is to assign the node voltage, and we have 3 essential nodes other than the ground. So we have V1 here, V2 here, and V3 here. And that's what we are gonna calculate. Well, we then do the third step, that's to apply the KCL. We apply KCL to each of these 3 nodes. So let's assume all the currents flow away. We have V1 minus V3 divided by R1, and plus V1 minus V2 divided by R2, plus V1 minus 0 divided by R4 is equal to 0. Similarly, for node 2, we have V2 minus V1 divided by R2, and because the current flows into this node, so we use minus Is, and plus V2 minus V3 divided by R3 is equal to 0. For the third node, similarly, we have V3 V2 divided by R3 plus V3 minus 0 divided by R5 plus V3 minus V1 divided by R1 is equal to 0. And for this question, we know all the values for the resistance, and the Is very similar to the last equation. We have this as 4, this is 5, this is 6, this is 5, and this is 4M. And we have R3, that's 8 ohm, R3 8 ohm, R5 8 ohm, and R1 4 ohm. And similarly, we can simplify this equation, these 3 equations. Use the method you like, and I recommend the substitution, and that's the way you are going to use in your midterm. So we can solve V1, V2, and V3. V2 and V3. So we have V1 is equal to 13.9 volt. V2 is 26.04 volt, and V3 that's 13.9 4608. Question P2.53. Solve for the node voltage shown in figure P2.53, then find the values of Is. The question asks us to find the value of Is. Is here is here. To find the Is, we first need to find the node voltage V1. V1 is here. After we find V1, we also find the current flows through here and here, and then perform the KCL to find the Is. Well, so let's first do the nodal analysis to find the V1. So let's go through the 4 steps. First, let's select the ground. It has selected for us, that's here. And then let's assign the voltage, and it has also done for us. This is V1 and this is V2. So let's directly jump to the third step, the most essential step, that's to perform the KCL. Well, for this question, we have 2 nodes to perform the KCL, that's V1, node 1 and node 2. But we found that between these 2 nodes, we have a voltage source. Well, so this is the second step of a circuit we see in the lectures. That's type 2B. We have the circuit with voltage source, and the voltage source is between 2 non-reference node. That's here. Well, in this case, we can form a supernode and perform the KCL for the supernode. So this whole thing becomes a supernode. Well, so let's then perform the KCL for the supernode. Let's similarly assume all the currents flow away from the node that flows away from here, and here. And let's write the KCL equation. Have this as V1, so V1 minus 0 is divided by 5 plus V2 minus 0 divided by 10, and plus, because here the current flows into the node, that's opposite as what we assume, so we use minus. We use minus 1 is equal to 0. And for when we are performing the KCL for a supernode, we can get another equation that's to describe the difference between the 2 nodes, which 2 nodes we form to become a supernode. In this case, that's node 1 and node 2. And here we can see that node 1 is connected to the positive terminal, and node 2 is connected to the negative. Well, typically, the positive terminal connects to a higher voltage node. So V1 has a higher voltage than V2. So we can write V1 minus V2 is equal to 10 volts. V1 is 10 volts higher than V2. Well, so we have 2 equations and 2 unknowns. So we can easily solve for V1 and V2. In this question, we have V1 is equal to 6.667 volts. V2 is negative 3.333 volts. Well, we have V1. We can calculate Is. So we have V1. We perform KCL here, and we assume all the currents are flowing away. Similarly, V1 minus V2 divided by 5 volt plus Is and plus V1 minus 0 divided by 5, that's equal to 0. And we substitute in V1 and V2. We are going to be able to calculate Is as equal to negative 3.333 amp. Last question, question P2.54. Determine the value of I1 in figure P2.54 using node voltage to solve the circuit. Select the location of the reference node to minimize the number of unknown node voltages. And the question also asks, what effect does the 17 ohm resistance have on the answer? Well, the question says that we can select the location of a reference node to minimize the number of unknown node footage. Well, typically, it's a good idea to choose a node that's close to the footage source if you want to apply the nodal analysis. And in that case, we can minimize the number of equations we have, the unknowns we have. So we can choose the node here to be our ground. Then we have this as then our second step is to assign the nodal voltage. So we have this as the same node as V1, and this as node V2, and this as the same node, let's say that's V3. So we are going to have 3 unknowns and 3 equations. But what's good is that because V1 is here, and this is ground, we know that the voltage here is 0. And in this case, that's our type of circuits we learned in lecture, that's B1. Because we have a voltage source. This is a circuit with voltage source, and the circuit source is on the side of the circuit, here. So we have V is equal to 0 here, and with this voltage source, 0 plus 25 volts, we have V1 directly get its value to be 25 volts. So immediately we only have 2 unknowns, V2 and V3. However, if you choose somewhere else as a reference node to be the ground, for example here, well, so we cannot fully make use of this voltage source to help us reduce the number of equations and unknowns. So it's a good choice to have our ground placed here. Well, so let's use nodal analysis to solve this circuit. We have finished the first 2 steps, so we can directly jump to the third step. That's to write the KCL equations for the circuit. Okay, so let's start from node 1. We assume all the currents leave the node. In this case, because we have already got the value of V1, so we don't need to write one more KCL equations. We can directly use this value. So we have already found V1. Then let's go to node 2 here. We assume all the currents leave the node. And here, the 3 amp currents entering this node. So that's minus 3 plus V2 minus V3 divided by 2 plus V2 minus V1 divided by 5 is equal to 0. Well, here it's important to notice that here the V3 is not our ground. It's not the reference node for this question. So it's not 0. Well, then let's continue to write the KCL equation for the node 3. Node for V3. And we have current flowing away, current flowing away, current flowing away, current flowing away. So the equation is, this is plus 3 amp, the same direction, and plus V3 minus V1 divided by 2 plus V3 minus V2 divided by 10, and the same direction, that's plus 4 is equal to 0. We have all the V1 is equal to 25 volt, 25 volt, 25 volt. So now we have 2 equations and 2 unknowns, that's V2 and V3. So we can easily find the V2 and V3. So we have V2 is equal to 25 volt, and V3 is equal to 5 volt. Well, The question asks us to find I1, and I1 is here. It flows from node 1 to node 2. We directly applied Ohm's law. So I1, that's V1 minus V2 divided by 5. And we substitute in the number we have, V1 here and V2 here. Sorry, here the V2 is 15, not 25. So we have 15 minus 25 divided by 5, and we have I1 is equal to 25 minus 15, and that's the value we are gonna get is 2 amp. So we have the I1 is equal to 2 amp. The last equation we have is, what effect does the 70 ohm resistance have on the answer? Well, you can see that in this problem, we never use the 70 ohm resistance in our calculation. It does not appear in any of our 3 equations, so it actually does not influence our result, our calculation for V1, V2, and V3. So as long as there is a resistance here, our answer for V1, V2, and V3 would not change.